Welcome to Basic Brewing Radio for Thursday, July 5th, 2007. I'm James Spencer. Here at Basic Brewing Radio, we're all about home brewing. With this week, we enlist the help of two chemistry professors to help us evaluate 5 popular formulas for predicting bitterness in beer. How accurate are they, and should we be concerned if they're not? Also, we celebrate 100 episodes of Basic Brewing Radio. If you're new to home brewing or would like to get into the hobby for the first time, check out our website, basicbrewing.com, where you can find archives of our audio and video podcasts and our DVDs to walk you through basic and more advanced brewing techniques. Well, I hope everybody had a safe and happy July 4th. I know that we did around here. We burned up a lot of gunpowder around around the Prairie Grove area, and we had a blast, literally. Now, I'm not going to spend too much time in the pre-interview portion today because the meat of our show is pretty long, but I do want to take a minute to thank everyone who has helped to build this show into what it's become. In the beginning, to be honest, it was just a way to get the word out about our DVDs, and it worked in doing that. But since then, it has grown to be much more. It is an animal unto itself. In the beginning, the podcast was supporting the DVDs, and now, in a way, the DVDs are supporting the podcast. So it's interesting how life turns around things in some ways. Over the past 2 years, I've been very fortunate to have many, many experts on brewing join us on the program. We've had some fun with some experiments of our own even, and we've learned a great deal. And many of you have written in and have also told me in person how valuable you think this program is, and I'm very grateful that you think so. I know my beers have improved over the past 2 years, and I hope yours have too. And if you get a lot of information out of this show, it's not because of me most of the time. It's because of the people that we talk to on the program, and I'm very grateful for all the time that all the experts have given to us to share their knowledge. And that's what homebrewing's all about. It's about sharing knowledge and improving the hobby as a whole as we go along. And today we have a show that will appeal to the more hardcore brewers out there maybe, but newbies should get something out of it too. We've enlisted the help of two chemistry professors, Bradley Sturgeon, assistant professor of chemistry with a specialty in biophysical chemistry at Monmouth College in Illinois at the Department of Chemistry and Biochemistry there. Brad is a recognized BJCP member and has listened to all of the Basic Brewing episodes, he says. So there you go. He's gotten some continuing education there. And Paul Charlesworth is a native of Great Britain, so he sounds like he knows what he's talking about, thanks to his accent. Paul is associate professor of chemistry at Michigan Tech in Houghton, Michigan, and Paul is also a longtime Basic Brewing Radio listener. Now, I met both of these guys through email thanks to this podcast. It was through email conversations that the idea for this episode arose. Brad had told me a long time ago that he had experience in doing chemistry analysis of beers, measuring things like international bitterness units or IBUs. And in a separate discussion, more recently, I was commiserating with Paul about how difficult it was for me to get consistent results between formulas that were meant to predict IBUs using recipes. I was trying to get IBUs measured for the recipe that I submitted with my the article that I wrote for Brew Your Own magazine, and I was getting different results from different methods. So anyway, luckily we were able to coordinate the efforts of Paul and Brad to come up with what you'll hear today. Also joining us on the program are Andy Sparks, Steve Wilkes, and Mark Smith, who you've heard on previous episodes, and I'm extremely happy that those guys were able to join us on the program to celebrate the 100th episode milestone. So here we go. How accurate are your IBU predictions? And what does it mean to your brewing? Well, okay, let's get started. This is perhaps the most technically unwieldy show that we've ever done. This is the official 100th episode. I don't know if it's technically the 100th episode, but I'm going to call it the 100th episode.
Just pitch it to him where it goes.
And what the voice that you've heard there is Paul Charlesworth, calling in through Skype in Houghton, Michigan. Say hi, Paul.
Hello.
And what do you do?
I am a chemistry professor, and I teach mostly first-year chemistry.
And also calling in through Skype is Brad Sturgeon.
Hey there.
And tell us what you do, Brad, and where you teach.
Yeah, I'm also a chemistry professor at Monmouth College in Illinois, and I'm the resident physical chemist, but have a love for analytical chemistry as well, and hence my tie-in with all the beer. And
you also do some evaluation for some chemical evaluation for a brewery as well.
Yeah, that's right. I've spent some time at the Wild Goose Brewery in Frederick, Maryland. It's owned by Flying Dog, and I've done some work with them and working in their lab, trying to get their methods all in tune so they can make sure their product's good.
So you actually have some credibility. You actually do the physical testing.
I think I've done this IBU measurement in the lab probably over 100 times, and I've even brought my analytical chemistry students in, and we've done this as a lab, and they've done the tests. And so not only have I done it, but I've pretty much taught a variety of other people to do it too. So I'm pretty confident in my abilities to do it, but it's not all that difficult.
Well, there you go. And here in the studio is... well, since this is the 100th show, I'll bring in the guy who was with me with the first 3 shows, Andy Sparks of thehomebrewery.com.
Hey, James, it's great to be here. I'm really thrilled to be on the 100th episode.
And the guy who was on the first video podcast and continues to be on the video podcast and our DVDs, Steve Wilkes.
And I, too, am very happy to be here. It's been a long journey from college when we were drinking Schaefer Light and going, there's got to be something out there.
And why does my head hurt so
much?
Why
does my head hurt so bad?
And then a more recent addition is Mark Smith from up in Benton County with the Dry County Brewing.
Yeah, I'm thrilled to be here as well, James. Congratulations on the 100th episode. That is awesome.
Well, thank you very much. And we have something in common in our 3 locations, geographic locations. We each have a bottle of La Folie. So shall we open? Oh,
yes.
That must have been Brad.
Flyer.
Yes, sir.
Check out a window.
Good job.
It's a foamy beer.
Well, here's to 100 episodes, 2 years, and many more to come. And thank you very much.
Cheers.
Congratulations. Cheers.
We are here not to talk about sour beers, but we're here to talk about bitterness in beers, and specifically international bitterness units, or IBUs, and measuring IBUs and predicting IBUs in our beers. And let's start with Brad up there in Illinois. How do you actually, what is an IBU, first of all, and how do you measure it?
The hops essentially contribute 3 different aspects to the finished beer. That's aroma, flavor, and bitterness. Those first 2, aroma and flavor, are very hard to quantify or to assign a numerical value to. But the third one, the bitterness, is something, as you mentioned, the IBU unit can be used to identify what the bitterness level of a particular beer is. As you know also that this is such an important value that the style guide put out by the Beer Judge Certification Program has acceptable limits for a particular style for the IBU measurements. So now hop flowers are very complex, and when we're talking about the bittering components, we're essentially talking about alpha acids. And when we take those hop flowers, pellets, whatever form they're in, and we put them into our boiling wort, we convert those alpha acids over into isoalpha acids. Now, something that's a little more technical, that isoalpha acid is actually short for isomerize or isomer. And what that really means is that the alpha acid, you don't change the number of elements in there or the type of elements, but what you do is you rearrange the bonding of those elements. So these are called isomers, meaning they have the same elements, but they're connected in a different way. And the most important thing that results from that is that the isomerized alpha acids then have a greater solubility, and then they can go into your finished beer. So the IBU, the technical definition of it, is that 1 IBU is 1 milligram of an iso-alpha acid dissolved into 1 liter of beer.
So it is a specific measurement. I mean, this is a specific amount of this isomerized alpha acid in a specific volume of beer, and that can be scientifically evaluated.
That's right, and it's kind of like, you know, when you pick up a can of soda and you look on the label and it says 39 grams of sugar. You know, if you had a beer label and it said isomerized alpha acids, it would say something like 30 milligrams, and so that would be 30 IBUs.
So how do you go about measuring these things?
There is an organization, the American Society of Brewing Chemists, the ASBC, and they have a fairly expensive book that is called Methods of Analysis. And just about anything that you want to know about a beer is listed in this method of analysis, from raw materials to finished packaged beer and all that. And the method that I use specifically that they have in their book is what is called Beer-23 Method A. This is not necessarily available online. I've done some searches on it just recently to see if you could find it. This is a great reason to visit your brewery if you want to go in there and ask them if you can see their methods of analysis from the ASBC. It's a good way to get in the door there. So, but the first thing that you have to do when you have a beer in hand is that you need to extract or take those iso-alpha acids out of the beer. And the way you do that is you add a small amount of an organic solvent on top of a certain quantity of beer. Now, this sort of analogy, organic solvent kind of discussion, is like an oil and water mixture. That if you have an oil and water mixture, the water is essentially the beer component and the oil is the organic solvent component. And these iso-alpha acids are much more soluble in the organic phase or the oil phase. So if you shake those up really hard in there, those alpha acids will transfer from the beer into this organic phase. All right, so once you've extracted the iso-alpha acids from the beer using this organic solvent, you place it into the UV visible spectrophotometer. And what the UV visible spectrometer does, essentially it shines light into the sample, and it makes the comparison between the light that was shown into the sample and what comes out of the sample. And if you had a lot of iso-alpha acids in your sample, then the light that's shining in will get absorbed, and then less will come out. So depending on the amount of the iso-alpha acid that you have in your sample, you absorb more or less of the light. That absorbance of light is essentially a numerical quantity that we can measure, again, by comparing what we shine in and what comes out, and that absorbance value is then directly related to IBUs.
So needless to say, we can't do that at home.
Oh, really?
At least, you know, most of us. So Paul, what tools do home brewers use and professional brewers if they want to predict the IBUs of a finished beer? What can we use at home to kind of get an idea of what kind of IBUs that we're going to have in the finished product?
Well, my understanding is that the large commercial breweries don't actually calculate their IBUs in the same way that the home brewer would. They attempt to brew the beer repeatedly and actually do the experiment that Brad was describing. They obviously have the equipment there. They measure their IBUs, the actual values, and then they would blend to get the kind of consistency you would expect from some of the large commercial breweries. I'm not quite sure about like a small craft brewer or a small microbrewer. They probably would follow the methods of the predictions. And probably the way we tend to do that is to look at the amount of hops that we add, the alpha acids of the hops that we add, the amount of time we boil, the gravity, and also whether we're using hop pellets or hop cones. And we actually do a series of predictions using what are known as utilization formulas, or sometimes they're called utilization methods. And you can either do this by hand, or the way I do it is with the Beer Tools Pro software, which has most of those formulas built in. And there are literally 12, or at least 12, I would say, formulas that are out there, and you can, as I said, you can calculate them on, piece with a pen and paper. But the ones that I've been interested in are just the ones by Jackie Rager, by Mark Garretts, by Randy Mosher, by I think Greg Tinseth, and by Ray Daniels, and those seem to be the most common ones that are out there. Each one has its own little way of doing this. Some of them look at just boil time and also wort gravity. Some of them look at boil time, wort gravity, and hop type. And each one has its own formula.
I think we can discuss the kind of nuances of the formulas as we go on. But these formulas try to take all the variables, the wort density, the hop pellet alpha acid percentage, whether it's pellets or whether it's whole hops, the amount of time in the boil, and they all try to, all of these factors, they all try to massage them together in such a way that they get an accurate prediction of IBUs. But what brought this all about was that I was trying to predict the IBUs of the recipe that I included with the BYO article, the six-pack Simcoe Ale, and I put it through Daniels by hand, and I got one number, and I put it through ProMash, and I got another number, and I found another IBU calculator online, and I got another number. So it was odd to me that, these formulas that have been around for so long could be so wildly different in their prediction of IBUs, and I didn't know which one to pick.
Yeah, and I think part of the problem there is that I think ProMash uses the Rager formula. You were calculating one with the Daniels formula, and I don't know what the other one was you were doing, but some of the studies I've been doing, there can be as much as 600% difference between some of the formulas.
Yeah, 600%.
600%. So that, if one was 10, the other one would be 60 for the same beer.
I mean, this is, and beginning brewers are probably tuned out by now, but needless to say, this show is for advanced brewers, and hopefully, people who are becoming advanced brewers, because, calculating IBUs is one of those things where if you enter contests on a regular basis, like Mark, calculating IBUs for you, Mark, is an important process, isn't it?
Absolutely. If you're trying to brew to style, if you're off by 600%, if you have 60 and you meant to get 10, you're completely out of style at that point. So,
you could actually be a bit too low as well.
Absolutely. You'd mentioned ProMash. I believe they have 3 different options you can choose. Rager,
yes.
I know, is one of them. Tinseth, and I think Mosher is the other one. But I go through and use ProMash almost all the time, and I'm interested in which one is the most accurate to the actual tests.
Yeah, and I think the other thing that should be made clear is that once somebody has picked a formula, they should stick with that formula, because changing the formula is not going to make your beer any more bitter or less bitter. Only changing the hops and the boil time is going to do that. If you don't stick with one, you're going to be getting all sorts of confusion there. So.
And Steve comes from the other end of the spectrum where, Steve, have you ever calculated an IBU?
I have. I've made an attempt at it. But exactly, it seems to me that it's an issue of picking, one way to do it and sticking with it. I mean, once you get a particular scale and you know that at least on your scale, 40 IBUs means something, and you know what that something means, then you can continue to make that something. But where Mark is a competitive brewer, and he's going to send his beer off to somebody who doesn't know him and doesn't use his scale, he's got a real different issue than I have. And it makes me ask the question or think about the days when we were sorting out Betamax and VHS and all these kinds of things. And is that the discussion that we're having?
Well, I don't think so, because as Brad said, an international bitterness unit is a scientifically evaluated quantity. It is a certain quantity of isomerized alpha acid and a certain quantity of liquid. And the fact that these formulas come out with these wildly varying predictions for this, to me seems it to me is a real quandary, because if we're just brewing to, for our own preferences, and we pick one formula that we like and we stick with it and we kind of know what we're going to get since we use that formula, that's one thing. But if you're a competitive brewer and you're trying to match certain styles and you're using one formula and I'm using another formula and we submit beers to the same category, one may be out, one may be in, they both may be out. It's a variable that's out there. What do you think, Andy?
Well, it reminds me of the keynote that we just saw at the NHC, where Peter Buchart basically said, I can make a beer with 32 IBUs that tastes like it has 20. Mm-hmm. So is the 32 the number, or is 20 the number? I don't know.
Yeah, that's the thing is that, Ray Daniels talks about balance, and you can have a beer that has a bitterness unit versus gravity unit, and that's how you determine what's actual perceived bitterness. Is you can have 40 U's in a 1060 beer, and it'll taste different than 40 IBUs in a 1080 beer. But we've designed a little experiment to so now let's go from the abstract now into the concrete. We've designed an experiment, and I've sent 6 beers to Brad to evaluate, and we've sent those 6 recipes to Paul to run through the formulas to predict. So what we're going to do is pick each beer, and Paul, you have told us which beers you've ranked the beers in the levels of variability.
Yeah. So what I did was I used the Beer Tools Pro software on the Mac, and it comes as standard with the Rager, Garrett's, Mosher, Tinseth, Daniels, and then it also has some sort of proprietary Beer Tools ones, but we're interested in these 5 at this point. I use the default settings. You just pull it down on a pull-down menu. You choose Rager. It quickly recalculates. In fact, it's instant, and it spits out a number for the IBUs. And then I worked out an average for each beer, and I worked out a standard deviation based on how far all of the formulas deviated. And then I sent those to you, and we're going to sort of go through each beer, starting with the lowest standard deviation.
And the lowest standard deviation was Mark's Hefeweizen.
Yeah, the German Hefeweizen.
And tell us, from a 30,000 feet level about that beer, Mark, and the hopping strategy that you had in that.
Well, it's pretty simple. It was an extract beer. Being a German Hefeweizen, it's not going to have a whole lot of bitterness to it. It was just a single addition at 60 minutes, and it was a Tettnanger, 1 ounce of Tettnanger at 60 minutes, and that was pretty much it. So
this is hopping at the start of the boil, and it had the least deviation. So
yes.
So run us through the numbers there, Paul.
All right. So for the German Hefeweizen, the average IBU was 15. Standard deviation was 2. And the Rager formula spit out 17, Garrett's was 12, Mosher was 14, Tinseth was 15, and Daniels was 17. And I want to just point out something ahead, just to sort of jump in ahead of time. so that people can notice this. The Garrett's formula always was the lowest, and the Daniels formula was always the highest.
Huh.
And the Rager, Mosher, and Tinseth were generally pretty close to the average.
Okay, now comes the drum roll. Brad, what's the actual number?
Yeah, the number that I got using the method was 7.
7.
Wow.
Whoa.
Half.
Somebody didn't boil it properly, did they?
Wait a minute now.
And this is actually the big problem with predicting IBUs, is that you think you're boiling for 60 minutes, but it could be 5 minutes, 10 minutes either side. You're getting up to boil and coming down from boil. If you live at altitude, you may be boiling, but you could be boiling at a lower temperature, and it's not clear to me whether it's the boiling, the agitation or the temperature that's important. And in fact, there are corrections for all of those things. You can correct for altitude, you can correct for yeast flocculation, and all sorts of crazy things. So it's not all that surprising that we're going to have some that are way off.
So, wow, that's shocking. The first beer, we're already shocked.
Yeah, I mean, there are some I was going to predict would be way off, but that wasn't one of them.
If there's one thing that, from a chemistry standpoint, with something like a sort of a wheat beer where you have a lot of particulate, it's very possible that some of that suspended material in there can complex with the different hop components, and may choose not to be extracted as readily. So the chemistry is the chemistry, but this is not a simple situation. And if you had some of those iso-alpha acids complexing with sort of some of the suspended yeast and all that, then your number should be a little bit lower.
That's pretty much what happened, I think. Yeah.
Yeah.
And you predict, and looking at your brewing notes, I think you predicted that, right, Mark?
Oh yeah, right here. I got them written down right here.
The question is whether the beer tastes good.
Yeah. Well, I'm sure it did.
I mean, that's all that really matters ultimately.
Brad, did it taste good?
Yes. Yeah, it was good. I think the bottle that I have a note here that it was a low fill.
It was a low fill.
That German wheat was a low fill. Yeah, I don't know how that would affect the results at all. As far as IBUs, I wouldn't predict it would have anything to do with it, but it was a decent beer. Yep.
Okay, we'll move up.
Not very hoppy.
Not very hoppy. Yeah. Okay, well let's move up the scale.
Next one on the scale
with one of mine, which is the Belgian Brunette.
Yep, Belgian Brunette. That has I don't know if you want to describe the.
Oh yeah, that part.
Yeah. So
I guess I better do my homework here.
Yeah, so you have just a single 60-minute addition, but you actually got a Styrian Golding and a Hallertau addition, both of them just thrown in at 60 minutes.
Right, and so this is the single hopping event.
Yeah,
as a weatherman would say, at the beginning of the boil at 60 minutes.
Mm-hmm.
What was the quantity?
0.85 ounces of Hallertau and half an ounce of Styrian Golding. 6% alpha acid on the Golding and 5.3 on the Hallertau.
Well, you keep better notes than I do.
I have them up on the computer screen here. So.
Okay, so drum roll.
So drum roll. The average IBU for this one was 26. Brad's probably going. Rager predicted 30. Garrett's 22, as I said. Mosher 23. Tinseth 23. And Daniels came in at 30. So actually Rager and Daniels tied. And the standard deviation for this was 4. So we got a little higher standard deviation, but the Mosher, Tinseth, and Garrett's actually are fairly close together. They're within the human tolerance range for detecting. So.
Okay, Brad, drum roll. The actual number.
Yeah. The number was 18.
Gosh.
You can't boil either.
Neither one of us can boil worth nothing.
That's going to be the next T-shirt. Can you boil your water?
Yeah, forget about flocculation. Can you boil? Wow.
Now, how old is that beer?
Oh.
Because aging also decreases the IBUs.
Okay, well, I can tell you that. It was brewed on January 6th of
this year.
07, yeah.
Okay, so it's not that's not going to be a significant aging. Then.
No, these are recent beers. So still, that's like, just around half of what Daniels would have predicted.
Mm-hmm. Yeah. So Garrett's wins again.
Wow. So yeah, I should be circling Garrett's, but still well, actually not too far off. 18.
No, I mean
22.
Garrett's, Mosher, and Tinseth all come in pretty close to that one.
Okay. And the next is
next in line is your vanilla porter.
Oh, and by the way, how was the Belgian blonde, Brad, or the Belgian brunette?
Oh, it was nice. It was slightly cloudy, is my notes that I have on here. But it was pretty fresh tasting beer.
So we're not winning. Mark, you and I aren't winning any points on the technical side or the tasting side either.
Well, sorry, I'm kind of an analytical person. So it's hard for me to quantitate those sorts of flavors. So I feel much more comfortable in the lab working with chemicals and all. So,
Brad, didn't you say that you are now a certified beer judge?
I'm only recognized.
Oh, okay.
Don't take what I say too personally.
There you go. Yeah. Stick to your gas spectrometer there, Brad.
Yes.
Okay. Next we move up to the vanilla porter, and that was hopped at 60 minutes, 15 minutes, and 5 minutes.
Yes. And so we have an average IBU of 24. A standard deviation of 4.9, so 5, give or take a bit. And Rager came in at 27, Garrett's at 18, Mosher at 23, Tinseth at 22, and Daniels at 31.
Okay.
Drum roll.
All right, Brad.
Can we guess first?
Wait. Andy wants to guess.
Well, it looks like it's going to be 18.
We should start putting some money on this.
Andy's going to put his money on 18. Okay, Brad?
Vanilla Porter came in at a 27.
Wow.
Whoa.
Higher than we expected.
Wow. So 27 was right on. Rager was right on with that one.
Some late hops in that one.
Yeah. And that could be the effect that you're already up to full boil by the time you add the next two. So you're getting some extra utilization. I mean, that's just a guess, but there's so many factors that go into this.
Okay, next is the 6-pack Simcoe. This is the recipe that I used for the BYO article. It was hopped. It was only hopped the last 15 minutes of the boil. In fact, the boil was only 15 minutes long. So we have hopping at 15 minutes, 5 minutes at flame out, and then a dry hop.
Yeah, this was pretty amazing, actually. I mean, considering you only boiled for 15 minutes, we got an average of 41 IBUs, which is just incredible.
Well,
it's the volume of
you must have been just squeezed in the hops or something. However, I will say that the standard deviation jumps up to almost 18 with a 17.5 standard deviation. And Rager comes in, and this is where it starts to get kind of interesting, because Rager comes in at 37, Mosher at 42, Tinseth at 48, but Garrett's comes in at 15, and Daniels at 63.
Wow.
Mm-hmm.
Wow.
So this is where I'm talking about the close to 600% difference between Garrett's and Daniels.
Yeah, and I was going by the Daniels number because I was trying to get the hopping, the IBUs, close to the gravity units, because I was trying to get a hoppy, nice hoppy beer. So what do we got, Brad?
Hey, James, could you just clarify the dry hopping? I mean, you did that once the beer cooled down and you...
Yeah, the dry hopping was after primary fermentation had completed.
Yeah, you see, that's interesting, because the dry hopping, I don't know how the calculations work with that. With the steep, I think the Rager and Daniels, where you've got the 0 time, But I think even the Beer Tools Pro software separates out steep from zero boil. I'm not quite sure how it does it, but it's kind of interesting. A different calculation going on there.
So what do we got, Brad? What's the number?
The number for the 6-pack Simcoe is 34.
Whoa.
That's actually not too bad, really. The percentage difference is pretty good.
So Rager was the closest on that.
Yes.
And Daniels was like almost
Way
twice
off.
as much.
Yeah. Not far off twice. But,
And then Garrett's was half.
Garrett's was half. Mosher and Tinseth were above. Looks like about, a third above or something like that.
So wow.
Yeah.
Okay.
I was expecting to be a bit closer to this, sort of in the middle, around the middle point, judging by some of the things I'd read in the literature about other experiments that I was expecting to be closer. But
Okay.
anyway,
And now we're moving up to the late hopped Simcoe ale.
Hey, James, you've quit asking me about my sensory perception.
Oh, yeah.
I'm supposed to take some offense to that, maybe?
Oh, yeah. What did you think of the... Did I ask you what the vanilla porter tasted like?
Yes.
And what about the
No,
6-pack Simcoe?
Yes, you did.
Man. Note to self, send no more beers to Brad. Okay.
so how was the 6-pack Simcoe? You didn't describe that one, right?
Yeah, well, actually, it's been a while since I did this analysis, so I have a few notes down here, but that wasn't my primary objective. So I contemplated filling out one of the BJCP scoring sheets on it, but once I get in the lab, I'm kind of on a roll. So
You're dodging the question. You're a chemist or a politician?
He's not a very good politician.
sometimes it takes both. All right, so moving on.
Well, Chris Colby liked my beers, so there.
Maybe we'll just sort of whistle and walk around in a circle for a bit. It'll be fine.
James is starting to cry. Come on now.
Yeah.
Just say it's good.
Yeah, in my own house, on my own podcast. Okay. Hey, I do have editing power, so Okay.
Just have the word. It's like have Brad record the word. It was great.
Yeah, and
Best beer ever.
And I'd like to thank our special guest Paul Charlesworth today for. Okay, all right.
We're actually going to record me doing the IBUs.
That's
later.
exactly. I'll just transcribe what Brad said, and no, I'm just teasing Brad.
No, that's fine.
Okay, the late hop Simcoe again. It was boiled it was a malt extract beer, so it was only boiled for 15 minutes, and again, two and a half.
Here you got a 10.1 minute boil, based on the calculations you sent me.
A 10.1. Well, it should be a 15-minute boil.
Right.
Two and a half ounces of Simcoe at 15 minutes. 1 ounce of Simcoe at 5 minutes. Half an ounce at flame out, and an ounce of Amarillo at dry hop.
Okay.
So, what do we got there, Paul?
All right. So the average IBUs for this, I did it on 10.1, and I could recalculate it a little bit for you at another time. But the average IBUs were 38. The standard deviation was 19. The Rager formula came in at 37. Mosher at 38. Tinseth at 39. Garrett's came in at 10. And Daniels came in at 64. Now I just quickly adjusted for the Daniels one, and that going from 10 to 15 minutes jumps his from 64 to 68. So you could probably add a little. So we're looking at some interest. I mean, Rager, Mosher, and Tinseth are all on the same page. Garrett's and Daniels, this is definitely a 600% off.
Wow. So Brad, what's the actual number?
For the late hop Simcoe ale was 34.
There you go. Mm-hmm. So again, Rager on that one.
Yeah.
So was that very similar to the 6-pack Simcoe then?
Yeah, I actually it was a matter of scaling. I just basically scaled the late hop Simcoe recipe down to the 6-pack. So I was shooting for around the same IBU. So at least technically, I did okay there. So
Yeah.
Oh, actually, I just readjusted for the Daniels one. It comes out at 74. I actually have a custom one in where I use Tinseth plus Mosher's hop additions for my personal stuff. And I just quickly checked, and the Daniels one comes in at 74 based on that. I'll just quickly recheck what the Garrett's is. 18.
Oh, well, a little better.
Yeah, it's still not winning any prizes, but
So, okay. So tell us about your IPA, Mark, which was the final beer that was tested.
I wanted to get rid of lots and lots of hops. So I did a technique that I kind of heard about, I guess kind of a West Coast technique where there's a lot of late hops added to get bitterness rather than a bunch of hops at the front. So I hopped the heck out of this one. 10 gallons, 18 ounces of Cascade hops, 2 ounce additions at, let me see here, 90, 60, 30, 25, 20, 15, 10, 5, and then 1 minute. So
yeah, this sounds like something Sam Calagione would make.
So, Paul, what are the numbers run?
Right. So we have an average of 85.
Okay.
A standard deviation of 21. Rager comes in at 91. Mosher at 83. Tinseth at 78. Garrett's comes in at 57. And Daniels at 116.
Broke the century mark.
And Brad?
The number for that double IPA is 77.
Oh.
So Tinseth wins the prize.
And which formula were you using, Mark?
I was using the Rager formula, and according to ProMash anyway, it came up a little bit less than that. It came up at 70, but, Paul's the chemistry guy, so
well, there's no chemistry going into this. I'm just plugging numbers into the computer, so I'm just using whatever the software does. So according to the way you did it, it's actually you're spot on, right?
Well, it says 70.2 was the estimated IBUs according to what I printed off here on ProMash, but
now we did have some discussions over email about like boil volumes and evaporation loss. So that can make a huge difference, which is why I kept emailing you back and forth to get the numbers right.
Right, and that's probably where the deviation is.
But needless to say, that this shows you that if two homebrewers brewed the same beer, and one used the Daniels method, at least using this piece of software, and one used Garrett's, you would have Daniels measuring the IBUs at twice as much.
So you would have a less hoppy beer than you think.
Yeah, and it's like somewhere in the middle there.
Anywhere from half as hoppy to 1/6 as hoppy as you were expecting.
If you're a home brewer out there and you're wanting to pick a formula, it looks like to me that depending on your hop schedule, some of these formulas might perform better than others.
I did do a couple of little graphs which I thought might be a little helpful. I took the average and I plotted each formula against the average, and it seems sort of the Rager, Mosher, and Tinseth ones tend to track the average closest. But as I think I was saying earlier, the reality is that you just pick a formula and stick with it, and you adjust according to taste. And as we were thinking about for the competition, I did look up on BJCP, and I could not find anywhere where you actually quote what you believe as the IBUs. You put in your hopping schedule, but you don't say I believe this is 100 or 200 IBUs. You just put in the hopping schedule. So I imagine you would taste your beer before submitting it to make sure that it's in the bitterness range that you think it should be.
I would ask or think about if you're you're brewing for yourself. Maybe the most important thing to do is to just educate your palate, to drink a lot of good beer from good places, and to know that if I'm making an IPA in a big Avery style IPA or something like that, or a Dogfish Head, that you know what you're shooting for and you know what it tastes like, and maybe the numbers don't matter all that much.
Yeah, I agree. I think from an artistic perspective of brewing, I think it's the taste and what you feel is right when you drink the beer that matters. The actual numbers, like you say, are not all that important. But from a scientific perspective, it's one of those things that just sort of you enjoy tweaking the numbers, I guess.
So Andy, is Peter Buchart closer to the truth than maybe all these numbers are?
Well, I think so. I mean, it is all about perception, and I know it's a measurable calculation here. This is how much alpha acid is isomerized in the solution. But I wonder if we did an experiment where we tasted the different levels. Is that, do you taste those levels? Is the measurement the same as what we perceive? I'm not sure. And I noticed that some of the most complex hopping schedules that we had in this experiment looked like those Rieger did pretty well on those, whereas some of the other more simpler ones, a different one scored better on those. And that's kind of what I was interested in. Is that this is really popular now to do these highly complex hop schedules, and does one break down when you start to really play with it?
Yeah, I was a little, as I said to James in some emails a while back, I was concerned about the idea that Rieger had that you start at 5% utilization for 0 time. And clearly that doesn't cause any off-the-wall problems. I mean, his formula tracks the average pretty close. So there's clearly no major problems that I can tell from having that 5% utilization at 0 time. But then most of the hop additions are in 5 to 10 minute intervals anyway.
One of the things that I find interesting is that we sometimes do a tasting where we want to help new homebrewers get an idea of hop flavors, aromas, and that sort of thing. And what we'll do is we'll just put some hops in a cup and put a little hot water like a tea, steep it like a tea, where it doesn't actually boil at all. And you definitely perceive some bitterness to it when you taste the solution. So, I mean, some bitterness comes off even without a boil. Obviously, not very much, but some.
Yeah, so maybe Rieger, the idea that you can get as much as 5% at 0 time is correct. That
actually, can I make a small comment on that?
Sure.
This is Brad. Actually, one of the things that if you take a hot flour and put it into boiling water, it's very possible that some of the alpha acids that have not been isomerized still exist in that cup as an oil on the surface. The whole process of fermentation and all this stuff and getting rid of your trub and all that sort of stuff, I think can take away any of those volatile oils. But in the case when you just add the flours directly into hot water, there could still be some oils on the surface that are perceived very differently or perceived as bitterness, even though they're not actually solubilized in the isomerized alpha acid form.
So there are some perceptions that are going on there that aren't necessarily measured by the scientific equipment.
Exactly. Yes.
So, Mark, what do you take away from all this?
Well, looking at the numbers, it does look like the Rieger formula does provide a more accurate prediction of IBUs for the more complex hopping schedules for the late hops that we sometimes like to use. The single 60-minute additions, it was a different formula. And I think most importantly, like Paul had said, is I don't know that you necessarily want to use 2 or 3 different formulas. Stick with one formula and just go with it, and then your perceived bitterness can adjust that through time. Through the beers that you drink, the beers that you brew, you can adjust that.
So even though I tend to use the Daniels formula because I have his book and the formula is printed in there and I love to run it by hand. it may not be the most technically accurate as far as the actual IBUs measured, but if my tongue gets used to measuring, in a more abstract method, and gets, saying that a Daniel's 116 or whatever, a Daniel's 75 tastes like this, then that's what counts. Because other than this experiment, I'm not going to send my beers off to someone to actually run the chemistry, and I'm not even probably going to enter contests. So Paul, I guess you're right in that if you pick one formula, it doesn't matter if it's really technically correct.
Yeah.
If it's what you use and if you're used to using it, then that's okay.
Yeah, I think if you've been using a particular formula for a while and you know that Daniel's at 100 IBUs tastes about right for what you like, then that's where you go. The fact that Garrett's predicts 10 IBUs is neither here nor there, I don't think. Or, that the others predict somewhere in between. It's really what tastes right, and I think you have to dial in your taste and maybe just ignore the actual numbers themselves. I mean, they're from a scientific or from a nerdy perspective, to want to give a better term, the numbers are kind of fascinating. You adjust the number of hops to get exactly 70 IBUs, and then you change the formula and it jumps to 100 or drops to something else. And the reality is that the bitterness is not going to change. It's just that your numbers are changing.
But from as you say, a nerdy perspective, looking at the purely late hopped beers, and especially the late hop Simcoe, having a low of 18 and a high of 74, and the actual IBU being 34.
Yeah,
that's an eye opener.
Yeah. The only issue I have with is if you want to try and you might be working from Ray Daniels' book, or you might be working from the BJCP, and you want to brew a beer that you've never brewed before, and you want to brew it so quote unquote to style, and BJCP says that you should have 50 IBUs in there. Now, have they measured those IBUs in the way that Brad has done it, or have those IBUs been calculated based on what home brewers in competitions have submitted beers? Then where do you go? And that's the problem I have with it.
That's a good question.
Well, Paul, I think you touched on something that's kind of interesting and close to my heart, is the competitions. And you'd mentioned that are they actually, physically testing these beers and these different styles to come up with the IBUs? And I don't know that it really matters, because they don't go through and test the beers that you're submitting. It's a perceived bitterness is what it is.
Yeah. And
I think that's something that we have to keep in mind here, that everybody's bitterness levels are different. I mean, it's you're 50, maybe you're 45, and my 35, And I think that's important to remember when you are submitting beers to competitions, and, take the feedback, and that can also help you adjust your IBU levels and your tweaking of your formulas.
I think that this has been a valuable experience. I think that, like I say, this is an episode for advanced brewers, because there's a lot of kind of data to wade through. But I think that at least it's a start of a good discussion, and we actually have run these formulas through and have got some actual scientifically supported numbers to test the results. Now, whether that will back people away from their favorite formulas and calculation methods or not, that's to be seen. But at least it kind of opens the door to a discussion that maybe we need to be looking at the way that these are measured. And I appreciate you guys, Paul and Brad, for all of your work. And I appreciate Mark and Andy and Steve here in the studio for all of your work as well, sipping on beers.
Yes, it's a lot of fun. Thank you for the Luffily.
You're welcome.
Yes. We should probably have a final toast to James and his success in this podcast.
Oh, shucks.
Oh, yes.
But, let's, instead of just toasting to me, let's just toast to everybody who listens to this podcast on a regular basis and all the future listeners who will be finding this episode in the archives. Here's to homebrewers out there all over the world.
Cheers. Cheers.
Cheers.
Cheers.
Well, thanks again to Brad, Paul, Andy, Steve, and Mark. Very thought-provoking stuff, to say the least. And I'm interested to hear what you think. Also, a special thanks to Mark and Andy for bringing over some excellent beers for after the show. Man, it's good to have good friends with good taste and access to good beers. Next week, our coverage of the National Homebrewers Conference in Denver continues. I'm not sure what we'll have next week, but we've got a lot of stuff in the can to choose from, so it's got to be good, whatever it is. If you have brewing questions, show suggestions, or just want to say howdy, write to james@basicbrewing.com or fill out the contact form on basicbrewing.com, and please don't forget to tell us where you're from. And while you're on our site, you can check out our online shop, where you can find great pricing on our DVDs and a combo deal to save you even more. In our first DVD, Introduction to Extract Home Brewing, we walk you through the extract brewing process step by step from boiling to bottling. And in Basic Brewing, Stepping into All Grain, we take you through the all grain process from milling your grain to collecting your wort. We do infusion mashing and step mashing and fly sparging and batch sparging, and all in a kind of nonlinear way, so you can pick your way through. You can see a listing of the fine folks, the growing list of fine folks across our country who sell our DVDs on basicbrewing.com. And if there isn't a vendor in your area, you can order it from us online, and we can pack it up for you ourselves. Shirt sales still brisk, and a lot of you are, augmenting your wardrobe with our Basic Brewing apparel, including our Go Forth and Flocculate shirts, and we appreciate that. And as usual, thanks to everybody who's continued to click on our Amazon.com link. We appreciate the support there. Our featured products this week that were purchased through the link are Fujifilm FinePix S6000 6.3 megapixel digital camera with 10.7 times wide-angle optical zoom with picture stabilization. Whew. And on the other side of the fence, It's All Too Much, an easy plan for living a richer life with less stuff. So we got you covered either way. Home brewing will let you enjoy life whether you like stuff or not. So there you go. Thanks again, everybody. And remember, I can't tell who bought what, so no worries. Just click on the Amazon.com logo on our site the next time you feel like Amazon shopping, and we'll get a little slice of that pie there. We appreciate your support. And that's it. That's all until next month. The next 100. Starting in the next 100. Wow. That seems like a big hill until you look back and see that we've come a long way. Enough philosophizing. That's all until next week. Until then, thanks for listening. I'm James Spencer. Production help for Basic Brewing Radio and our website is provided by Kelly Dodson. Basic Brewing Radio is a production of Active Voicing. We'll talk to you next time, everybody. So long.